So let f be in the set of continuous functions in the closed interval from a to b, and c be a constant, a real constant. How do we define the function multiplied by the constant c? That's a scalar multiplication, as we will show. So we define CF by CF equals to the set of order pairs xy such that y equals c multiplied by f of x. So the real number c times the real number f of x. Now, in abbreviated notation, we will simply write the following. The constant times f evaluated at x equals to the constant times f of x, f evaluated at x. This is scalar multiplication when it comes to functions. We have a function and we are multiplying it by the scalar c. Now, it obeys 5 properties: closure, scalar multiplication, associativity, scalar multiplication, identity, there is an identity element, and scalar multiplication distributive properties. There are 2, where the scalar distributes over function addition and where scalar multiplication distributes over scalar addition. Let's verify that scalar multiplication of real constants by functions, continuous functions on an interval from a to b, closed, satisfies all scalar multiplication properties. Let's begin with a scalar multiplication closure. So let f be a continuous function on the closed interval ab, and let c be a real number. That's our scalar. Now, what we want to establish is that the scalar product, the scalar multiplication CF, is also a continuous function in the closed interval AB. This is a theorem of calculus. So CF is also contained in the set of continuous functions in the interval from A to B inclusive by a theorem of calculus. Which asserts that the constant multiple of a continuous function is continuous. Now we want to establish the scalar multiplication associativity. So what do we have? we have a continuous function on the interval from a to b inclusive, and two constants. So C1, C2, and these are real numbers, two real constants. What we want to verify is that the function that arises from the scalar multiplication of C1, C2, and F, that equals to the function that arises from the scalar multiplication of C1 and the function C2F. The way we are going to accomplish verifying this is by writing the meaning of the scalar multiplication of C1, C2, and F, and deducing that that ends up being the meaning of the scalar multiplication of C1 and the function C2F. Okay, so let's begin. I want to write C1, C2, F evaluated at X. What is that equal to? Our definition for scalar multiplication says that this equals to the constant C1, C2 multiplied by the real constant fx. So this is multiplication of real numbers. C1, C2, that's multiplication of real numbers. F of x is a real number. Now, since multiplication of real numbers is associative, I can transfer the parentheses. So since the structure of real numbers under multiplication is associative, the latter, so C1 times C2 multiplied by f of x equals to C1 multiplied by C2 multiplied by f of x. What is the meaning of this? This is the scalar multiplication. What's inside the parentheses, excuse me, is the scalar multiplication of C2 and the function f evaluated at x. So you get C1 multiplied by the function C2f evaluated at x. But this is scalar multiplication, so what is the meaning of that? That is the function C1 multiplied by C2f evaluated at x, which is our right hand side. Now we verify our third property, that of scalar multiplication identity. So there is an identity element in scalar multiplication, 1, the real number 1. So very easy to verify. So let f be in the set of continuous functions on the closed interval from a to b. Let's verify that the scalar multiplication of 1 and f is just f. So what is the meaning of the scalar multiplication on 1 and f? it means that 1f evaluated at x equals to the product of 1 and f of x. But we know that 1 is the multiplicative identity. So 1 times any real number is that real number. So we end up with f of x. So confirmed. The function 1f evaluated at x is the same as the function f evaluated at x. In other words, those two functions are equal to each other. Let's proceed to verify the scalar multiplication distributive properties. So there are two. Let me mention both of them and then verify them. So let f g be continuous functions on the interval from a to b inclusive, and let c be a real constant. The distributive property here is the following. The function c f plus g equals to the sum of the functions cf and cg. Our other distributive property says the following. Let f be a continuous function on the closed interval from a to b, and let c1, c2 be real constants. Then what we get is that the function c1 plus c2 f equals to the sum of the functions c1f plus c2f. Now, let's differentiate between these two distributions and then proceed to establish them. In our first property, we're saying the following, that scalar multiplication distributes over function addition. So CF, CG. So scalar multiplication distributes over function addition. Here we're seeing the other role switch. Here scalar multiplication distributes over scalar addition. So here the multiplication distributes over addition of functions. There scalar multiplication distributes over addition of real numbers. Okay, so let's verify the one on the left. So verify that equality. So let's start with the left hand side. I want to express the meaning of the function c f plus g. So the function c f plus g evaluated at x equals, our definition is the following. The constant c multiplied by the constant f plus g of x. Now we know the meaning of f plus g of x is f of x plus g of x. So we write that. So c times f of x plus g of x. So this is multiplication of real numbers. That is addition of real numbers. Now we know that multiplication of real numbers distributes over addition of real numbers. So let's do that. So let me write the reason. So since multiplication in R distributes over addition in R, the latter, so C multiplied by f of x plus g of x equals to c multiplied by fx plus c multiplied by g of x. Now each of these terms is a scalar multiplication. So what is c times f of x? It means the function cf evaluated at x. So the function cf evaluated at x plus, similarly, c times g of x is the function cg evaluated at x. So here I have a function evaluated at x plus another function evaluated at x. By definition, that is the sum of the functions evaluated at x. And that's the meaning of the right hand side. What is CF plus CG evaluated at x? What you see prior to that. Let's verify our second property, our second distributive property. So verify that second property. So we begin with the left hand side. So what is the meaning of the scalar multiplication of C1 plus C2 and F? Well, it means that C1 plus C2 F evaluated at x is simply the product of the constant C1 plus C2 and the constant F evaluated at x. Now, that's addition of real numbers, that is multiplication of real numbers. So I once again appeal to the fact that multiplication of real numbers distributes over addition of real numbers. So what do I get from that? I'm going to get C1 multiplied by f of x plus C2 multiplied by f of x. Now I look at each of the terms. What is the meaning of C1 times f of x? It means the function C1f evaluated at x plus, what is the meaning of C2 times f of x? It means the function C2f evaluated at x but now I have the addition of two functions. So I have C1f evaluated at x plus C2f evaluated at x. What is that? That is the function C1f plus C2f evaluated at x as we were intending to obtain.